how many bonds it makes, how many bonds it, meaning the element, it makes to complete its valence shell. So don't forget, nonmetals are gaining, right? They're not going to lose. They're going to fill it. So basically, how many electrons it's short. How many electrons it's short. Every bond contains only 2 electrons. Bonds contain 2 electrons, and 2 electrons only. So if you make a bond, most of the time, one of the electrons is yours. The other electron is coming from another atom. Together, for both of you, you've just increased the number of electrons that are around you by 1, right? Because you're sharing your electron with another atom who's sharing its electron with you. So now you both have 2 instead of 1. And I'm going to show you visually what that means too. Now, if you think about it, if you look at a periodic table, with the exception of the first row, most atoms want to end up in the right-hand column, the noble gases, which for the first 2 rows the second and third row means 8 electrons. So we often call this the octet rule. They want to be surrounded by 8 electrons. There's a couple of exceptions to that, and I'll tell you those. So they want to be surrounded by 8 electrons. So we call this the octet rule, oct for 8. Phosphorus and nitrogen, okay? Arsenic can too, but once we go below the staircase, now we're talking about more metallics. So there's no sharing. Okay, 2. Who has a combining capacity of 2? Oxygen. Sulfur. One more. Selenium. Okay. Boron also has a combining capacity of 3, but it is an exception to the octet rule. It only wants to be surrounded by 6 electrons. It does not want 8. So boron only wants 6 electrons total. Elements with a combining capacity of 1 will never be central atoms. Elements with a combining capacity of 1 will never be central atoms. We call them terminal atoms. As they're on the end. So your central atom will be an atom with at least a combining capacity of 2. When we make our Lewis structures, the one with the highest combining capacity is the central atom. All the other atoms that are bonded to it will end up being around the outside. Hydrogen only wants 2 electrons total. It only wants 2 electrons total. All the others in combining capacity of 1 will be surrounded by 8 electrons. Hydrogen will only have 2. Combining capacities for metals depends on how many electrons they lose. They don't form the same types of bonds as our nonmetals, and you're going to be representing them differently. But think about combining capacity of 3. Who can lose 3 electrons? You have a lot of it probably in your kitchen. Very flat and in a big roll. Aluminum. Aluminum will lose 3 electrons. So will the 3 elements listed below it. TL. So gallium, indium, and thallium. Has anybody seen the trick with gallium spoons?
And they put them in water and they dissolve.
Yeah, you put them in water and it melts the spoon. Okay, I'll show you. I'll show you right after this. It's it melts at around 29 degrees Celsius. So mercury is the only element that's the only metal that's liquid at room temperature, but there's 3 others that are really close, and one of them is gallium. It's a nice silvery metal, so you can make it look like a spoon, but when you stir it, it actually melts it, and you get this big puddle of gallium metal. No, you still can't drink it, but it's really cool. Number 2, who's got a combining capacity of 2? Who wants to give up 2 electrons? Beryllium? Who else? Kyle, give me one more. Magnesium. What do we call that whole column? The alkaline earth metals, yeah. So that's group 2. And then, of course, your combining capacity of 1 is your alkali metals. Group 1. How many valence electrons does hydrogen have? Thank you, Kyle. 1. Should put a dot. Make sure it doesn't look like a random dot. Helium, how many valence electrons? 2. Lithium, 1. Now beryllium has 2, but I want you to do them differently than we did for helium. I want you to separate them. First one on top, second one to the right. Boron, 3, 1, 2, 3. Notice that we're adding an electron as we move across because the atomic number is increasing. Carbon has 4. Now nitrogen has 5, so what happens is now we're going to start doubling them up. And you go clockwise by convention, meaning this is the way everybody does it. Oh, I can't move it now. Shoot. And then neon, of course, has all 8 around it. Okay. Your page is bigger than my board. Okay, so now these electrons that are singles are called unpaired electrons. Where they're doubled up, these are lone pairs of electrons. Lone pairs of electrons. Okay. So electrons want to be in pairs as much as they can. So do you see now why carbon makes 4 bonds? Because it wants a second one at each one of these spots. Okay? And electrons will try and space themselves apart from each other as much as possible, which is why there's one on each side. So you'll have a bond here, 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 and here. Nitrogen has a combining capacity of 3. It's going to make a bond here, here, and here. Oxygen, only here. It's missing 2 electrons. That's why it's going to make 2 bonds. If you put them in pairs, 2, 4, 6, there's nothing here to bond. You haven't given it any electrons. So we separate these. Fluorine's only missing 1. Neon has all 8. Okay? So this is why they form their bonds. Now, those should really change this to lithium and fluorine.
Eliza's channel. I've been to one of those guys. You watch my channel, like your channel.
I gotta go look for it. Oh, Jesus, I got this.
All right, so what you're going to do now is you can see that sodium's got one valence electron and it wants to form an ion, so it wants to give it up. So what you do is you show an arrow. That electron is going to go over here. Then that means that your sodium now is missing one electron, and it's an ion. You have to put square brackets around the Bohr diagram and put the charge. So it's positive because it lost one, and it's a 1 plus because it was one electron transferred. Beside it, you're going to draw the chlorine. It took that electron, so now its outer shell is full. And it has a 1 negative spot. Do you remember doing this in grade 10? No? No? Yes? Some? And how are you going to show the formation of an ionic compound? Do the Lewis structures for the atoms, and an arrow, bless you, and then you're going to show me the Lewis structure for the compound. If I say to you, draw the Lewis structure for sodium chloride, this is all you're going to do. Okay? This is Lewis structure for the compound. The whole thing is if I ask you to show me how it forms. Calcium has none, it lost 2. Fluorine gained 1 twice. So you can put a subscript 2, but you still, the charge is 1 minus. Because each fluorine only gained 1. But there's 2 of them. Another way to draw this, you could put calcium in the middle and draw 2 fluorines. 1 on each side. Or you can be lazy and put a 2, which is what I am. Right? The other one would be a fluorine, a calcium, a fluorine. Fluorine has 8. Okay?